I had my first attempt and time got the best of me, says Jordan. You're not alone, man. But that is a great comment, okay? I'll tell you right now, that's a great comment. That goes to show you, it's not just about knowing electrical. It's not even about knowing your code book, right? It's about knowing how to manage your time. And that's a big thing for your licensing exam. And that's a big thing I teach in this book, right? 4 minutes per question is a big thing, okay? By West Point, okay? Do you know if the California test is hard? I think all exams are difficult, but honestly, brother, I've heard so many testimonials of people from California passing their licensing exams because of my book. California and Texas are the two biggest states that I hear from of people passing their licensing exams. California does not allow your code book. Okay, I didn't know that. Let's answer question number 17. That was a lot of comments talk. Okay, guys, this is a conduit fill question. Guys, I'll say this again. There's two types of conduit fill questions. There's easy, and then there's more difficult. This question is more difficult. The easy ones is where you have a question with conductors of the same size and the same insulation. But this question, we have two different sizes, and it looks like they're the same insulation. But because there's two different sizes, what we have to do is do Chapter 9, Table 5, and then Chapter 9, Table 4, and then we have to calculate, okay? So this is what I like to do. Guys, I have to stop looking at the comments just for a second, just so I can answer this question, okay? And I want to show you, this is how I answer these conduit fill questions, okay? So it says that I have two, okay? I like to write it out, two 3/0 XHHW conductors, and then I have two 4/0 XHHW conductors, okay? Two different sizes, same insulation, okay? So what we need to do is go to Chapter 9. What did I say? Chapter 9, Table 5, okay? Chapter 9, Table 5 to answer this question. Okay, Chapter 9, Table 8, Chapter 9, Table 5. Okay, we look at Chapter 9, Table 5, and we see dimensions of insulated conductors and fixture wires. So we need to keep looking until we see XHHW, which is the only type in our question, right? So let's keep going. Here we are. I see XHHW, and it says 3/0 and 4/0. Okay, this only goes up to size 2, so I do have to flip the page. XHHW, and we have 3/0, okay? 3/0 right here, and we need the inches squared. That's how much space it's taking up in the conduit in question, right? So 3/0 takes up 0.2642. So I'm going to write down 0.2642, okay? But we need to remember that our question says that we have two 3/0, okay? This is the amount for a single 3/0, but I have two. So I have to multiply this number by 2. So let me get my calculator. So 0.2642 multiplied by 2 gives me 0.5284. 0.5284. And now it's the same process with the 4/0 conductor. 4/0 is 0.3197. 0.3197, but again, that's not just one, we have two in question. So let's multiply that by 2, and it gives us 0.3197 multiplied by 2 gives me 0.6394, but now we need to add these numbers together to get the total amount of space being taken up by our conductors. So let's add those two together. 0.5284 gives me a total inches squared of 1.1678. Now that I have that, now I can figure out what minimum size LFNCB is required. So now we're going to go to Chapter 9, Table 4. Okay, and we're already here, right? Chapter 9, Table 4 is the dimensions and percent area of conduit and tubing, okay? But now we need to look at these bold headings of each table until we see our raceway in question. And the question said we have LFNCB, okay? Don't be too quick, right? You see A, B, and C, okay? We got to make sure that we're on the right one. Now that we're here, we have to select the minimum size conduit that can contain at least 1.1678 inches squared, okay? Guys, most of the time, we're going to use this column, over 2 wires. Most of the time, we're doing over 2 wires, okay? If we have a question in the future, I will specify when we have to use these other ones, but most of the time we're going to be using this. Now we're going to look at inches squared, right? We see half inch LFNCB can fit 0.125, but that's not enough, right? We need one that can fit 1.1678. So as we keep going down, I see that 2 inch can contain 1.298, which is larger than this number. That means that's the minimum size, right? If I go to 1.5 inches, it can't contain that much, right? It's not code compliant. So 2 inches is the next size up. Therefore, A is my final answer. Okay, I'm gonna say this again, Josito. I think you're asking how long is it gonna take for you to study so that you can pass. That's what I think you're saying, okay? I have had people tell me that they bought this book and it helped them pass within 2 weeks, right? They bought this book, 2 weeks of studying, they passed their journeyman licensing exam. I don't recommend 2 weeks. I think that's great. It's an awesome testimonial. I don't recommend 2 weeks. I recommend at least 1 month of studying. Between 1 month and 2 months is what I recommend. Listen, everybody's different, right? Everybody's different. Everybody studies differently. Everybody tests differently. There's no way I'm going to recommend 2 weeks, but between 1 and 2 months of good studying, I'm confident my book will help you pass your licensing exam. What's the name of the code book? Okay, so this code book is just the NFPA National Electric Code Book, the 2026 edition. If you're talking about my book, it's the Comprehensive Guide to Passing the Electrical Licensing Exam, available in the TikTok shop and will be available on Amazon soon. Oh boy, this is a long question. When installing a single-phase 120 240 volt emergency backup generator rated at 22 kW, the ampacity of phase conductors from the generator terminals to the first overcurrent protective device shall not be less than how many amps where the design of the generator does not prevent overloading. Okay, so again, guys, what we do is we look at keywords in the question. Some keywords, it's generator is the big keyword for me. Emergency is another keyword. Anytime it's emergency, it kind of screams special conditions, which is chapter, I think, 7. But regardless, generators, I do believe is article 445 maybe, but generators, the ampacity of phase conductors, okay? So we're looking for wiring capacity, conductor ampacity, okay? Of a generator to the first overcurrent protective device. Okay, so I do think the answer is going to be found in article, I think it's 445 for generators. I could be wrong, but I do know it's around there, right? Article 450 is transformers. I think it's between 430 and 450. So I'm just gonna say 445 is generators. But let's see, guys, comment down below if you know the answer to this question. Air conditioning, hey, here we are. 445 is generators. There are no part numbers here, okay? So we're gonna forget about the third step of our navigation method. And now we're just gonna look through, and we're looking for conductor ampacity or something like that, right? Okay, so I'm skipping. Oh, so guys, what I'm doing is, I'll tell you this, I'm not reading, I'm skipping, which is the best way to navigate your codebook, okay? Oh, this is article 450. Guys, what happened to my transformers? Oh, generators. It's such a short code article that I skipped it, okay? Okay, so let's do this again, okay? I'm not reading the text, okay? Article 445.11 says marking. My question says nothing about marking, right? So I'm skipping this and the A's, the B's, the C's, the 1s, the 2s, the 3s until I see conductors. Everybody see that? Article 445.13 says conductors, minimum ampacity and size. Overcurrent protection not provided. Okay, let's see what the question says. It says, the ampacity of the conductors from the generator terminals to the first distribution devices containing overcurrent protection. Everybody sees that? Everybody sees that this is verbatim to our question now? Shall not be less than 115% of the nameplate current rating of the generator. So 115% is the key number here. Guys, we have 400 people here. Thank you guys so much. I do appreciate it. Guys, but you're wondering, Aaron, the question didn't give us the nameplate ampacity, and you're right. But it did give us the power, which is 22,000, and the voltage, which is 240, okay? If you should know that your power divided by your voltage gives you your ampacity. This is just Ohm's law, right? 22,000, and it's single phase, so there's no 1.732 nonsense, right? So 22,000 divided by 240 gives us the ampacity of 91.67, but this says shall not be less than 115%. So I need to take this ampacity and multiply it by 1.15, and it gives us the answer 105.42 amps. Therefore, A is my final answer. This is peak Thank you very much for your effort in spreading this knowledge. God bless. King Explosion Murder. Thank you, man. I appreciate the kind words. That's a ridiculous name. How do I thank you with sincerity when your name is King Explosion Murder?